So we have two metal alloys we're going to use to mix to make a third alloy. So the first one has 30% nickel, the other one has 70% nickel. And we're going to mix those two alloys in a certain ratio such that we get 20 kilos of another alloy that has 48% nickel. So the alloy that we want to get, we know we're going to get 20 kilograms, and because it has a 48% nickel rating, then the actual amount of nickel is going to be 0.48 lots of 20, which is equal to, or indeed 28 lots of 0.48, and we're going to have, as an answer to that, 9.6 kilos of nickel. We don't know what the weights are of the other two alloys, but we know that because the first one has a 30% nickel rating, therefore then 30% of X is going to be nickel. And in B, it has a 70% nickel rating, and therefore we know that for a Y amount of weight, 70% of that will be nickel. And we have to appreciate therefore that those two amounts of nickel must equal the total of 9.6 that we want. And that's one equation with two unknowns. So we need one more equation, and we can say to ourselves, well, the two nickels, the two metals themselves, two alloys, will sort of add up individually to a weight of 20, or a mass of 20. And I might want to make myself life a bit easier by multiplying by everything by 10 for that first equation, so that I don't have any decimals. We're going to use these two equations to solve this simultaneously. So to solve this simultaneously, we're going to keep the first equation as it is, and we're going to multiply the second equation by -3. When I add those two equations, I get 4y is equal to 36. Therefore, y is going to be 9 kilograms. And therefore, x, well, since x and y together add up to make 20, then x will be 9 taken away from 20. So we have 11 kilos of the first alloy, and we have, for the second alloy, we've got 9 kilos.